If we can extend maximum lifespan, we're really doing something to the whole of aging. Whereas if we're only extending average lifespan in mice, then arguably that means that we're only hitting some aspects of aging and not all. However, the point here is that we should be aware of this difference and try to address it to the best of our ability.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live a longer, healthier life. We produce by InstaTracker, your science-based guide to optimize your body from the inside out. Our guest today is Dr. Aubrey de Grey. Dr. de Grey is an English biomedical gerontologist. He is the author of the mitochondrial free radical theory of aging and co-author of Ending Aging. Dr. de Grey is known for his view that medical technology may enable humans not to die from age-related causes. He works on developing medical interventions that can postpone all forms of age-related illnesses. His main focus is on rejuvenation, the active repair that various types of molecules and cellular damages that eventually cause age-related diseases and disability. Dr. de Grey is the Chief Science Officer of the LEV Foundation, and before that, he was the Chief Science Officer of the Sense Research Foundation. Welcome, Aubrey.
Thanks for having me, Gil.
Excellent. So I would like to start by a basic question, and the question is, what led you to become a scientist?
What led me to become a scientist was a very early experience when I was like 8 or 9 years old, when I started thinking about what I wanted to do with the world. That actually happened because I wanted to understand why I didn't want to practice the piano, because my mother wanted me to practice the piano. And I thought, this is a waste of time. And I thought about, okay, why is it actually a waste of time? And my answer was not because I'm not very good at the piano. I was thinking, well, potentially I could get good at the piano if I do this. But I then thought, well, okay, what's the best case scenario? Namely, I could become a good pianist. But that wasn't really good enough for me because I thought, well, there are lots of other good pianists already. So I thought, no, that won't do. I want to do something that very few other people can do well. And that's what led me into science.
Okay. And what have got you interested in longevity and in mortality?
Yeah, so that was a lot later. So I wanted to work in science in order to make a difference to the world, but I naturally had a lot of choices about which area of science. So eventually I went into artificial intelligence research because when I was 15, I started programming and found I was pretty good at it. So I thought, okay, this is an area where I can use my talents to make a difference. And that's what I did, and it worked out pretty well. I was quite happy with how my work was going through the 1980s. But in 1990, I met, and shortly afterwards married, a biologist. And through her, I learned a lot of biology by accident, but also, after a couple of years, I began to realize that we were never talking about aging. And the thing is, I had known since my earliest years that aging was a very bad thing. It causes a huge amount of suffering and death and so on. And also that it's an engineering problem, that in theory we should be able to keep the body going, same as we keep a car going or whatever. And I had never considered the possibility that other people didn't think that way. So I'd never discussed it with anybody. But eventually I began to realize that this is actually the case. And it wasn't just my wife, it was also, all the other biologists I was meeting through her. So I thought, well, this is incredible. But eventually, after a couple of years, I came to terms with it and decided, well, okay, look, the problem I'm working on with AI research is an important one. I'm working on the problem of work, the fact that people have to spend so much of their time doing things that they would not do unless they were being paid for it. But the problem of aging is a far, far worse problem. And therefore, since I have now established that I'm fairly good at working on really hard problems, because as I say, my research was going quite well, then, maybe I have a chance of making a difference in this other field. So I thought I'll switch fields. And I was in a position to do that. So that's what I did in the mid-90s.
Cool. And can you define the term biogerontology? What is that?
Sure. So let me start by defining the term gerontology. Gerontology is simply the study of aging. But that comes in various forms. So there are people who call themselves social gerontologists, and they're interested in studying the sociology of aging and, figuring out ways to maintain the dignity of the elderly, things like that. And then there are clinical gerontologists who simply are doctors who work on the health problems that predominate in late life and who try to alleviate those problems in just the same way that doctors alleviate problems of people in early life as well. So a biogerontologist is someone who studies the phenomenon of aging as a basic science, someone who tries to understand how aging happens, from the molecular and cellular level. Now, I actually don't call myself a biogerontologist. I call myself a biomedical gerontologist. And the difference there is quite important. Biogerontologists study aging as a phenomenon without any particular ambition to do anything about it, to actually postpone it or anything, but just to understand it. So biogerontologists are a bit like, seismologists. They understand that the thing they study is bad for you, but they don't really have any aspiration to stop it from happening. So a biomedical gerontologist is not that. A biomedical gerontologist is really a technologist, someone who wants to develop new medicines that will be able to address and minimize the problems of aging to a greater extent than what we can do today.
Excellent. That was a good definition and a good explanation. Thank you so much for that. And now that we understand this term, so what are the main reason that we age, or we call it in the aging field, the hallmark of aging? What are those? And which of them, in your opinion, are the most important?
Yes, so the hallmarks of aging is a term that was coined in 2013 by 5 very prominent gerontologists who wrote a paper in Cell that has become, by a huge distance, the most highly cited paper in the whole field this century. But it actually wasn't very original, because essentially it was a reworking of what I'd published a decade earlier. And that didn't annoy me particularly because, I get plenty of credit for what I did a decade earlier anyway. And because the Hallmarks paper in 2013 made far more of an impact. It was perhaps because it was published in a top journal and by, people with lots of credentials and everything. It was accepted much more easily than I had been earlier. But yeah, so what are these hallmarks anyway? Really, I think one has to look at, first of all, the reason why one would want to make a list of such things in the first place. And the answer for that, my answer, back in 2000 when I first did this, was I wanted to simplify the problem of postponing aging. I wanted to try to take all of the various things that go wrong with the body as we get older and classify them into a manageable number of categories so that within each category there will be some generic approach to actually addressing it and postponing it. And that was what I did, and I came up with 7 categories, which are, of course, talked about all the time now, the 7 deadly things. The Hallmarks people in 2013 didn't really go about it that way. They kind of classified what research was already being done and, what targets that research had. And they kind of then tried to structure it in some kind of, intervention-centric kind of way, but that was a bit of an afterthought. And that's kind of the reason why the original Hallmarks paper did not really stand the test of time the way that my version did. What has happened instead is that people have carried on adding hallmarks, and it doesn't really mean anything very much. It kind of misses the point as far as I'm concerned.
And so in your opinion, if we are going maybe 10 years back or as you see today, what are the most important hallmarks of aging in your opinion?
You mean of the original ones that I identified or the ones that were identified in 2013?
Yeah,
whichever.
whatever you believe today that they are the most important
Well,
for longevity.
okay, well, the short answer is one cannot answer that question, because the whole point of this classification, whether it's mine or anybody else's, is to identify, it's because aging is a multifaceted problem. The body's a really complicated machine. It does a lot of different types of damage to itself, and any of them can kill you on schedule, however well we fix all the others. So we don't really have, it's kind of counterproductive to give them any kind of hierarchy. There are other reasons to give them a hierarchy, but I wouldn't call them a hierarchy of importance, rather more a hierarchy of priority for research. And that comes from, essentially, how far we've already got. So at Science Research Foundation, my main focus was on the most difficult areas of damage, the areas that were not being worked on very much by other people, because other people have too much constraint of short-termism, because they need to make money or they need to get the next grant application funded or whatever. And so they don't work on the harder things. And those things were, lagging behind. And because you have to fix everything, it was important to have them catch up, if you like. And that remains the case. We still need to, when we want to work on individual bits of aging, we want, whether you call them hallmarks or anything, we need to make sure that we move all of them forward. At LEV Foundation, of course, things are a little different, because there what I'm doing is I'm taking some of these interventions that have already been developed against, let's call it, the easier types of damage, and putting them together in the same mice at the same time to get some kind of additivity.
Yeah. Okay, thank you for that. And the follow-up question for that is, we discussed that aging is a multifaceted process, and it's complex. And now we know that there are hundreds, if not thousands, of scientists that's working on aging right now. So it's become more and more popular to work on. I'm sure that when you started and when I started working on aging, that was 20 years ago, maybe there were only a few, and now there are many. And I know that in the aging community, there is a debate about, is aging a disease or not? And if yes, can we cure it? What is your opinion about that?
Okay, so first of all, no, there is no debate in the aging community about whether aging is a disease or not. That is a fictitious debate that doesn't really have any meaning, and it only goes on among the chattering classes of the wider world, not in the field at all. Aging is completely understood to be a medical problem. In other words, something that is bad for you. It causes decline in function, both mental and physical, and it's something that can potentially be addressed with medicine. And whether one wants to call it a disease or not is pure semantics. It just doesn't matter. It also doesn't even matter to the Food and Drug Administration in the US or its counterparts elsewhere in the world. People are terribly exercised about the importance of classifying aging as a disease, which incidentally has already happened on the part of the organization that does such classification, which is the World Health Organization. But it's not, that's of no interest to the FDA at all. The FDA are interested in making sure that any clinical trial that they have to look at in order to decide whether to approve a therapy has a well-defined clinical endpoint, such that they can look at the results of the trial and say yes or no, the trial did or did not achieve that endpoint. And if that endpoint has the word aging in it, then the FDA are going to have a problem, because the word aging means different things to different people. So the only thing the FDA wants is for clinical trials to say what they mean, right? That's all. Whether aging is a disease or not is irrelevant.
Okay. So what you are saying, the FDA would like to have an endpoint. I improve, decrease inflammation or decrease A1C, and it doesn't care more about a specific disease, but give me a right endpoint that I can judge whether you improved it or not. That's fair to say?
Exactly. And of course, the endpoint can be a complicated combinatorial one. That's exactly what happened with the TAME trial, this initiative to do a clinical trial on the effectiveness of metformin against aging, which was led by Nir Barzilai. Now, that trial has still not been funded, so it hasn't even begun. But that kind of doesn't matter. What matters is that nearly 10 years ago now, Nir and his colleagues went to the FDA with the description of the trial And they were able to hammer out a clinical endpoint that the FDA approved. The FDA said, yes, if you do this trial and it meets this endpoint, then we will approve metformin as a drug for anyone who is suffering from any of the conditions described in the endpoint. So the endpoint, of course, involved a whole bunch of the usual things that individually appear as clinical endpoints of, lots and lots of different clinical trials, whether it's, cognitive decline or high blood pressure or, things like that. So that was all straightforward. But putting them together turned out to be pretty complicated, but they did it. So it's already been done. The hard part has been done.
And do you know, or do you have speculation why the TAME trial haven't been funded yet?
Oh, that's obvious, because no one's going to make any money out of metformin. So the only way it can be funded is by philanthropy.
Because it's a drug that lost its patent. That's the reason.
Certainly, yes. It's been off patent since before you and I were born, probably. Yeah. And yes, but I mean, of course, the good news is that because it has been out there for so long, one doesn't need to do any safety assessments. One can go straight to phase 3 and determine whether it's effective. And that was and that's the plan for the TAME trial. But yeah, I mean, it has to be funded by philanthropy because that's the only way it's going to be done. And of course, philanthropists have a lot of choices as to where to put their money. And there are questions as to whether metformin is the right drug to be testing.
Yeah. Okay. So it's in a way a chicken and the egg that somehow we need to get out of it and make the first trial to cure aging.
Yes and no. If you're a pharmaceutical company, you've got a new treatment that you've developed and that you own the IP for, and you reckon that it is, going to be effective broadly against aging, then you can do your own trial with that same clinical endpoint that was already done. You just copy and paste it. And, that is something that I think is likely to happen in due course.
Okay. No, that's a very good point. So my next question is, can science reverse aging? And can we do that in our lifetime, let's say?
Right. So, of course, again, I'm going to be very careful with the word aging because, as I've said already, it means different things to different people. Whenever anyone says anything about aging that I think is nonsensical, my standard answer is to ask them to repeat themselves without using the word aging, and then they tie themselves in knots. So what you're really asking is, can we comprehensively repair the damage of aging, the damage that the body does to itself throughout life as a consequence of its normal operation? And I believe, yes, we can, but not yet. But we're quite close. The many, many different types of damage that accumulate during life have been classified by me, of course, into these 7 major categories. And for each of those categories, back 24 years ago, I described a way in which the damage could be repaired. Now we, of course, have moved on a lot, not only in implementing those various strategies, but also in identifying new strategies, alternative strategies for each of the various types of damage. So we've got plenty of options for getting this to work. And some of those options, in some cases, have already been developed to the point where they do work in mice. Now, a couple of them have got far enough to be in clinical trials. There are various stem cell treatments, for example. One of my favorite ones right now is stem cell treatments for Parkinson's disease, which is a really important aspect of aging driven by loss of a particular type of cell. Then there are clinical trials now for senolytics, for drugs that selectively kill off senescent cells. So we're getting there. And that's why it becomes so important to do mouse experiments that combine some of these things in the same mice at the same time and to determine the way in which to get the best amount of additive benefit. So that's where we are right now.
And that's an interesting point. And I know that in some diseases, like in cancer, you do a clinical trial, or not a clinical trial, you do a study in mice, and then the data is not translatable for human. So do you think that in aging, it is universal, and whatever you will see or we see in mice translate to aging? So translate to human?
So this is a very, very important point. And yes, actually, we do believe that we have a much better chance of higher hit rate, higher likely hit rate, that things that will work in mice also work in humans. But that's not because we're working on aging. It's because we're doing damage repair. The point about aging is that it's the accumulation of all these various types of damage, but the body is set up to tolerate a certain amount of that damage without significant decline in function. That's why we only exhibit that decline in function, whether mental or physical, late in life. So that means that this damage, this damage is accumulating throughout life, but it's initially inert. And inert means that it's not participating in metabolism. The fundamental reason why it's so difficult to predict whether a particular drug will work in humans just because it works in mice is because it is manipulating this insanely complicated and poorly understood network of processes called metabolism, right, that keep us alive from one day to the next. If you interfere in that, then you really don't know what's going to happen. And in particular, different individuals of the same species, let alone different species, have significantly different metabolic behaviors and metabolic, strengths and weaknesses. And so, so you kind of shouldn't be surprised that this is very difficult to do. But if you're repairing damage, and in particular if you're repairing damage before the person you're treating or the mouse you're treating has got sick, then you're not manipulating metabolism. You're just restoring the underlying molecular and cellular structure and composition of the organism to something close to what it was at an earlier age. So I believe that we have a much, much better chance of having things that do translate pretty straightforwardly from mice to humans.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At Inside Tracker, we take a personalized approach to healthspan optimization that eliminates guesswork from your wellness plan. Inside Tracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the Inside Tracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
Okay. And maybe one of the difference between lab mice and humans that live like us is that we can do whatever we want. The refrigerator is 20 feet from any place that you are in your house, and you can smoke and you can do a lot of things that the mice cannot do because we control them very well. So what do you think that is the effect of our lifestyle and nutrition and exercise on longevity?
So this is a very big question, and let me address what you've said in two different ways. First of all, for sure, there is already an effect of our lifestyle and diet and so on our longevity. It's pretty clear that you can shorten your life pretty effectively by smoking or by getting seriously overweight and so on, right? If you don't do any of those things, if you already behave the way your mother told you to, then actually, at this point, there isn't much you can do to do better than that. But that's what we can do today. So the other interpretation of your question comes back to your previous question about mice and so on. Fact is, you're quite right. Mice are living in a controlled environment in captivity. In particular, they're protected from infections. That's rather important. And so, it's not necessarily a good model to use. Now, I don't think that's going to matter all that much when it comes to looking especially at maximum lifespan. If we can extend maximum lifespan, we're really doing something to the whole of aging, whereas if we're only extending average lifespan in mice, then arguably that means that we're only hitting some aspects of aging and not all. However, the point here is that we should be aware of this difference and try to address it to the best of our ability. Probably the single most effective approach to doing so that is being used today is to do studies in dogs. And this is being led by a number of groups, especially the group of my great friend Matt Kaberlein. The idea here is that dogs have a bunch of things that humans don't have. One is that they are that mice don't have. One thing is they're closer in lifespan to humans than mice are. Okay, they live maybe 10 years, 15 years, depending on the breed. The other thing is that they're in the community. These are studies that are done with dogs that are living in the community. So they are exposed to infections, and they have very heterogeneous lifestyle and diet and so on. So in that case, that's pretty excellent. And of course, the only disadvantage is it takes longer to get results. Yeah. But definitely there's great value in doing experiments on dogs.
Yeah. And just for the audience, we interviewed Mike Kimberline a year or two ago, and we discussed in detail his dog research. And I agree with you. It's like in dog, in a way, the environment is more controlled. Still, the dog cannot jump to the refrigerator and take what he wants. But a lot of time when you eat dinner or lunch, you throw him a bone or something like that. So he is exposed to your nutrition more than, let's say, than mice. But also a lot of time he sleeps with you in your bed, and he is in the same temperature and the same environment. So the relationship might be much better with dog than a human, and it's a very good point. But absolutely, we have the drawback. They live longer, and it's harder and more expensive, and so on and so forth. So going back to the point about a lifestyle intervention, so I assume that our audience know about Brian Johnson and what he's doing with optimizing his body, taking 250 supplements and have 4% body fat and so on. What do you think about that direction?
So I'm a big fan of Brian, but I need to explain what I do and do not think he's doing right. The main reason why I'm a big fan of Brian is because he is completely fearless. He is perfectly happy to be ridiculed by people who don't know much, and indeed by people who do know plenty, right? He goes out and he just says, this is what I'm doing, this is why I'm doing it. And he doesn't let peer pressure get in his way. And I think we need far more people like that. I've always tried to be that kind of person myself. And, so I very much admire Brian for that. However, if I had $2 million a year to spend on my health, I would not be spending it the way he's spending it. Some of the ways he's spending it, I certainly would do. And one of those is measurement. One thing that Brian is extremely strong on is the more you know about your body, and of course, not just once, but in response to whatever experimental, changes in lifestyle or diet or medicines you might undertake, the more you know, the more effectively you're going to be able to optimize. So I agree with all of that. In terms of how he's making choices about what to do, how to do his lifestyle, I again think he's doing things largely correctly, but often it's misinterpreted. So one thing he goes on a lot about is sleep, right? He says, it's absolutely vital to have, solid, consistent sleep patterns. It benefits everything. And that's true, but just as with every other aspect of metabolism and lifestyle and so on, it varies a lot from one person to the next. So Brian has found that sleep is really important to him. And for quite a long time, he actually refused to take any trips, to do any travel that involved crossing more than 2 time zones, just so that he could avoid that. But the fact is it's not so important for some other people. I, for example, I happen to be able to sleep really well on planes. I basically don't have a circadian rhythm. I can sleep whenever I like. I don't get jet lag at all. So, for me, it's not nearly so much of a priority. And I think one thing that's often overlooked whenever anyone, whether it's Brian, whether it's Ray Kurzweil or anyone like that, comes out and talks about what they do, is there is a tendency to interpret it as a recommendation for that's what everybody should do. When in fact, the recommendation is pay attention to your body, do what works for you, right? Yeah. So then the thing that I really don't think Brian is getting right is, well, to put it bluntly, he's not giving me any money. In other words, he's not investing in new treatments that don't yet exist. He will not. He's very keen on this don't die thing, right? But he's going to die unless something comes along in time for him that does a very great deal better than anything he can do for himself today. He knows that, but he's not acting on it. So, something needs to change there.
Yeah, thank you for that. And I want to add a comment about what you said, and I agree with you 1%. some people, everyone is different. So you cannot come and say sleep is the most important. Yeah, it's most important for Brian, but it might not be the most important for Aubrey. Absolutely. And it's the same with diet. There are a lot of people that come and say, hey, paleo diet is the most important, or a low-fat diet, or high-fat diet. And it's not. It's you need to fit it for a person based on his own metabolism. And that's exactly what, in a way, we are doing at InstaTracker. We are trying to fit it to you based on looking at the data of your sleep for the last year and then providing you some recommendations. So I'm 100% agree with you about that you cannot come and say based on N of 1 to imply to everyone in the world. That's not the right way to do. And the second point that you said that I also agree with you, lifestyle and the exercise and sleep and nutrition, I think that it will allow you to get to the level, if you are lucky and you have a good genetics, maybe to the age of 122, because that's the longer live a person that we know about it for sure, but it won't allow you to break the limit. And to break the limit, we need to have a new discoveries. And that's something that we need to study, and that's something that you are doing. And based on that, I have a question to you about that. So there are now a lot of, and I'm very excited about it, a lot of biotech pharmaceutical companies that are trying to develop a drug to extend our lifespan. You mentioned a few of them, like senolytics and so on, but which one of those new target or new drug are the most promising in your opinion?
So this comes back to what I was saying earlier about the divide and conquer approach, about the fact that, there's lots of different things that go wrong in the body, and any one of them can kill you on schedule if we don't slow it down. So in other words, there is no answer to that question. The only way we can address aging in a useful way is by identifying a combination, a portfolio of interventions that jointly have, and now they cover enough of the bases, so to speak, to do the job. And that's why the experiments that we're doing at LEV Foundation are focused on exactly that. At the moment, we're doing a study that's nearly done, in which we're putting 4 different things together. The next study, we'd like to put 8 different things together to hit as much as we can about what goes wrong in mice. And the goal here is to get a big increase in lifespan, even though we will be starting these interventions when the mice are already in middle age. At the moment, if you take mice that normally live about 2.5 years on average, and you do nothing at all to them until they're 1.5 years old, so they've got 1 year left, then the best that anybody can do is to get about 4 additional months of healthy life and total life. Okay? Now, that's not nothing, but the point is we could already do it 50 years ago. Literally 50 years ago, we could already do that with calorie restriction. So, that's a pretty serious indictment of where we are. Now, the study that we're doing right now that's nearly done, we've also only got those 4 months. But that's because we haven't been comprehensive enough. That's our conclusion. We need to hit more things. So I believe that we have a chance of breaking through that barrier pretty soon, after 1 or 2 more attempts. I think that the goal that we've set ourselves is the right goal, namely to treble that amount. In other words, to get an extra 12 months, a whole year, rather than only 4. I think when that gets to be achieved, game over. Everybody will understand that aging is about to be solved.
Yeah. And can you mention what are the combinations that you are using, or it's confidential?
Oh, no, it's certainly not confidential. I post stuff about it on Twitter all the time, and it's all described on our website at levf.org. Yeah, so at the moment, the things that we're doing are rapamycin and young blood stem cells and telomerase gene therapy and a senolytic called navitoclax. That's a sensible combination of things, and, it's a starting point. We've definitely demonstrated that we're getting additive benefits. In other words, the group that is getting all 4 of these things is doing better than any of the other groups, but we need to do better than that.
Yeah. Okay. That's interesting and exciting. And speaking of which, there is another endeavor similar to what you do at the LEV Foundation, and that's the X Prize, but that's in humans. So they are Jamie Justic basically trying to find a group that can, let's say, they are looking in the opposite way because it's in human, decrease the age by 20 years for at least 2 different processes. And by the way, I interviewed Jamie in a episode about what she's doing a few months ago. So anyone that wants to listen to that, you can. What do you think about this approach of doing it directly in human?
Yeah, so it's not an accident that the specification of the X Prize looks very suspiciously similar to the specification of what I'm doing in mice, because I basically designed the X Prize. I was the main scientific advisor of the group that was doing that design a couple of years ago. I'm taking more of a back seat now, but I'm still obviously an advisor. So yeah, I mean, that's the thing to do. You want to try and get to rejuvenation. But remember, you don't have to do it this year or next year. You have to do it 7 years from now.
Yeah.
Now, honestly, I think that's exactly what X Prizes try to be. It's audacious, but it might be achievable. I think that I think we have at least a 50-50 chance of getting to my mouse goal of an additional 12 months of healthy life starting in middle age within the next 3 years from now. Okay? And, if we do that, then the race is on. But I think that it's just about possible that people will get at least a 10-year rejuvenation of people, maybe the full 20 years that they're looking for, within the next 4 or 5 years after that, which is, of course, what we're looking for. I would say that if I had to put a 50-50 guess on it, I would say it'd be more like 10 years following the mouse result. And that's why, at the moment, I say that I think that longevity escape velocity, LEV, will be achieved in the second half of the 2030s. But I would very much like to be wrong. I would very much like the X Prize to do what X Prizes do and to incentivize people to do it even faster.
Yeah. No, I didn't know that you are so involved in the X Prize, and I think that's an amazing endeavor. And so congrats on being a part of that team. And I would like now to maybe switch gear and talk about your background. So the first organization that at least the first organization that I know that you have been from the founder is the Methuselah Foundation. Can you describe what this foundation is doing and what was the goal of that foundation?
Certainly. So you're quite right. So when I started out in all of this, I had no idea how to get things done. I was just an academic. For the first 5 years, I was a harmless academic. I was having ideas that were, well received, but didn't piss anybody off. And then in 2000, I started talking about damage repair, and everyone decided I was crazy. But still, I was only talking to academics, pretty much. I mean, I had, a small following online, I guess. But this was, when the internet hardly existed. But one person that I came across during that period, around 2002, was this guy, Dave Goebel, who was a really, really visionary businessman in Virginia. One of his jobs was working for the government at the Department of Homeland Security. And he decided he wanted to join forces with me. He realized that nothing was going to happen without some kind of organization. He also realized that, there were things that I knew how to do, and there were very definitely things that I did not know how to do that he did. So he thought we would make a good team, and he didn't have any trouble convincing me that that was correct. So we created this thing. Actually, the Methuselah Foundation had been created as a charity, a 501c3 that had not yet done anything, a couple of years earlier in about 2001. And interestingly, Dave knew Peter Diamandis back then. They kind of worked together to create the X Prize Foundation and the Methuselah Foundation. And Peter was our first business advisor at Methuselah. So I've known Peter for a very long time. Anyway, so yes, at the beginning, we had no money at all. So what do? And we can't do research because research costs money. So instead, we did public relations. We decided that, okay, we want to raise the profile of longevity research and make it more respectable and more respected. And the way we do that is with prizes. Dave was already keen on prizes on account of that's how he got to know Peter. And so he thought, okay, let's make a Methuselah Mouse Prize. So let's give people money if they beat the world record for mouse lifespan. And we defined that record in 2 different ways, one that was kind of more of a headline one and one that was more rigorous. So What money? How will we give money if we don't have any? Well, of course, that was the point, right? We started saying, okay, give us money and it'll go into the prize pot. And we defined things in terms of the proportion of the prize pot that you get if you beat the record depends on how much you beat the previous record by. And so, yeah, that worked out pretty well. And we started getting significant money in. And the record was not broken. And the result was we had a bunch of money. First of all, it was enough for me to be able to quit my job in Cambridge and go full time. But then after that, we started to realize that we could do research. And so we started funding a couple of PhD students. Some of those people have become real movers and shakers in the field since that time. And as time went on, we realized that we could probably get more. And my first big donor was Peter Thiel, who gave us a few $1 million in the second half of the 2000s. Around 2008, we realized that we were having a bit of a messaging problem because we were doing these two very different activities. We had this PR thing with regard to the prizes, and we were also doing research. And for PR, you've got to be, terribly glitzy and populist and so on. And for research, you've got to be rather the opposite. So we decided that the right way to go would be actually to split the organization in two and to have one organization do research. And that ended up being the new one, Sense Research Foundation, which I led. And then the other one doing the prizes. And that was Dave carried on leading that one, which is still the Methuselah Foundation. Thereafter, as time went on, both organizations broadened somewhat. We did more advocacy as well as research. They did more research as well as advocacy. They started a kind of an ancillary entity, which was a venture fund, and were able to support a few startup companies. We also started a few startup companies as spin-outs of our projects. So, yeah, things have evolved over the years. But, Methuselah is still a very successful organization. I'm still very close friends with them.
Yeah, it's a very interesting story. And a few comments or points. First, Peter, for whoever doesn't know, he's basically the founder of X Prize, and it sounds like Aubrey, you know him for more than 2 decades, which is very good and interesting. My next question is about the prize for the Methuselah Foundation. So, how big was the prize at the peak of the prize size? What was the prize?
We were able to put a few $1 million together, not very much really, certainly nothing like the X Prize, but it was enough to get researchers interested. And the main thing was, it was making news. It was getting the word out. It was getting journalists interested. That's really the main value.
Yeah. And why, in your opinion, nobody was able to break the record and receive the prize? And first, what is the record? What is the current record of lifespan of mice?
Okay, so as I say, we defined it in 2 different ways. First of all, we had a headline one, which says, one mouse, doesn't matter what you do, you can mess around with the genes of its parents and things like that. And the record there was 1,819 days, if I remember rightly, which is almost 5 years. So that's almost twice as long as your average mouse would normally live, right?
Yeah.
But that was a genetic modification. And we realized that actually, people who are old enough to pay taxes or, have the misfortune to be already alive, they want to help themselves. And so that's not allowed. So we then said we want a second prize, which says you're not allowed to do anything genetic or indeed anything dietary or medical until the mice are already in middle age. And we defined it in the same way I just did earlier on in this conversation. You have to start at 18 months or more. Furthermore, we're not going to be interested in only one mouse. We want to look at a whole bunch of mice, and we want to see how much they live on average, or the maximum of the top 10% of mice, something like that. And it's got to be, a rigorous enough study that it was published. So for that, the record was, as I said, it was basically about 4 months of additional life on top of the 2.5 years that people normally manage, that these mice normally live. And that was never beaten. And I'm quite sure I know why it was never beaten, because nobody until now has been in a position to do things that are sufficiently complicated. The only thing that people have been able to do so far is essentially to emulate the way that it was done before, namely to give the mice less food than they would like, which elicits an evolved response to live longer, or to trick the mice genetically or in some other way into thinking they're not getting enough food when they actually are. That's how the transgenic thing was done, the genetic modification. It's how rapamycin works. It's how metformin works. You name it. It's basically how everything that has been shown to work so far works. In order to get past that, we have to do much more complicated things. And that's what the LEV Foundation's RMR, Robust Mouse Rejuvenation Research Program, is all about.
Okay. And in a way, what you do in your current foundation is, in a way, it's similar to what the NIH ITP is doing, correct? You are going a bit more combination, but they are also looking at different intervention and the effect of lifestyle.
So the ITP is a great deal better than nothing. But first of all, most of the stuff that they're doing is starting early in life, at like 4 months of age or whatever. Only a minority of their experiments are done starting at 18 months or more, a small minority. Second thing, they are, excuse me, they are only doing very few experiments in which they combine things. There are some, but only a small minority of their experiments involve more than one thing at a time. But the third problem with the ITP is the biggest one. They are only doing things that they can put in the diet, in the food of the mice. They're not doing anything that requires to be injected. So that means there's no cell therapies. There's no gene therapies. There's no immune therapies. It's a huge restriction. And I'm absolutely sure that they won't get any significant improvement over what calorie restriction can do while they limit themselves in that way.
Yeah. So you're saying they are more conventional, conservative, and you are trying to break the barrier and really get to the year or plus of extension. And they are just trying to confirm what others have shown, like in work in a model organism. Let's confirm it in mice, but not as exploration as what you are doing.
So I wouldn't quite go that far, but nearly. So the case of rapamycin is actually the biggest success story of the whole of the ITP. They found out it out by accident, but they found out that rapamycin does extend life even when you start late in life, around 18, 20 months of age. They only did that experiment by accident because they had trouble formulating the food, but the point is they did it. And that has caused, of course, this explosion of interest in rapamycin and molecules similar to rapamycin. Fine, but it only gets the same amount of life extension that calorie restriction does when you start at that same age. And that's no surprise because it works by tricking the mouse into thinking it's not getting enough food.
Yeah. Okay. And now I want to ask you a question that is more like in the 30,000 foot view. And you have been in the field of longevity and aging research for a few decades. So in your opinion, what are the key milestones of discovery in the longevity field that happened in the last few decades? If you need to, mention the top 3 or top 5, what are they?
Well, certainly the identification of the 7 deadly things, my original description of a classification and ways to go about eliminating these things, I would say that's still the single biggest breakthrough, simply because it was a complete paradigm shift. Everyone before that was thinking in terms of slowing aging down, trying to make the body run more cleanly and damage itself more slowly than it naturally does. And I was the first person to point out that actually repairing damage that's already been done not only will benefit much more people, because it will benefit people who are already in middle age or older, but also it's actually going to be a lot easier to implement than slowing aging down. So that really was the biggest thing, a conceptual thing, but still the biggest thing. Then the other things that have been really big, well, certainly you have to include things like the discovery of senolytics. But I think really the biggest things of all are ones that do not actually relate to aging specifically, but rather to biomedical research overall. So the sequencing of the human genome and, of course, other genomes, the development of really fast, cheap sequencing has enormously accelerated the whole of biomedical research. We're now seeing something very analogous with protein folding, with the development of AlphaFold, which, has been absolutely transformative in terms of drug discovery. Everyone has to use it now because that's the only way that one can develop drugs far more quickly than before. And now that's moving on, of course, to protein design, to identifying an amino acid sequence that will fold into the shape you want it to in order to bind a particular molecule, a substrate molecule, for example. These are absolutely immense. Beyond that, of course, stem cells, same deal, because certainly the discovery of the Yamanaka factors, helps the whole of biomedical research, but it's very, very important for aging research. That's why there are billions of dollars being poured into partial reprogramming at the moment, using those same factors to increase the regenerative capacity of cells in the body.
Okay. Yeah, thank you so much for that. And we don't have a lot of time left, so I have a couple of questions that I have to ask you, so I will try to squeeze them in. The first one is, how long can we live in the future, in your opinion? And I want to ask it go even further. Do you believe that in the future we can reach to 1,000 years old?
Sure. There's absolutely no reason why we should impose any particular number, any limit. The whole point of preventative maintenance is that it can be done repeatedly and increasingly comprehensively. So this is where the whole concept of longevity escape velocity came from. Once we get even 20 years of postponement of the health problems of late life with these rejuvenation, damage repair interventions that are applied to people when they're already 50 or 60 years old, we've done the hard part. It will be absolutely certain that we will improve the comprehensiveness of that portfolio of treatments within those 20 years sufficiently to be able to rejuvenate the same people 20 years later so that they will live another 30 years without getting sick, and so on. So, that's absolutely guaranteed. It's a bit like, vintage cars. If you'd taken someone 100 years ago who was building a car and you asked them, is there any chance that this car will be around 100 years from now, they'd have laughed at you. But if you ask someone today who has such a car, right, and you ask them, will this car be around for another 100 years? They say, well, of course, why not?
Yeah, no, makes sense. And my last question is, what is your top tip for health span and longevity for a person as of today? What can they do today in order to increase their health span and longevity?
Write me a large check. Simple as that.
Okay.
I mean, the fact is, at the moment, so long as you're doing what your mother told you to, you can't do much more. The only way that you can improve your chances of not getting sick when you get old is by hastening the development of treatments that do not yet exist. Now, you're doing that by interviewing me and educating your audience, right? Wealthy people can do it by writing me a large check. Less wealthy people can do it in other ways. They can talk to people who could write me a large check. They can also, if they're scientists, if they're biologists, they can go into the most impactful areas of biology, and I'm always available to give advice on that. There's a million different things that different people with different talents, different strengths and weaknesses and opportunities can do. But it's all about hastening the development of things that do not yet exist.
Okay. Thank you for the interesting answer for this question. And thank you so much, Dr. de Grey. We look forward to exploring the research in the field of longevity each month with you and other leading scientists. For more information, please go to www.instatracker.com/podcast. Again, thank you so much, and I appreciate your insight and wisdom.
My pleasure. Thank you for having me.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Inside Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out, using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.